Hey everybody, this is part 2 of this stoichiometry test review, stoichiometry in the mole, and we're going to be doing questions 11 through 24. Zoom out here so we can see. Well, I just finished the first 10 questions, so now let's head over to here and get and start with question 11. And actually, I'm going to I'll tighten in more so it'll be hopefully easier for you to see. I'm only going to do part A on these because for the most part they're almost the same thing, you're just using a different given. What I cannot say enough to you, draw yourself a very simple mole MVP triangle to use as a roadmap to help you figure these out, because just about all these problems are going to be involving converting from one compound, what we'll call the given in the problem. And then most of these are going to have, you're going to be required to do a mole-mole conversion section using the mole-mole ratio. And again, we have MVP, and we'll call this the find side. And don't be afraid to use that. So to begin with, in this problem here, we've got our balanced equation. We're looking for how many moles of Fe2O3 are produced. Okay, so that's what we're looking for. So I'm just going to, this will be the Fe2O3 side. Oh, let me, I guess we need to be able to see that there. Okay. So recommend to do that, and for this first one we're starting with moles of O2. So this will be my O2 side to begin with. This is the given side. So we're starting at moles of O2. So that's kind of nice. We don't have to convert from grams or molecules or liters. So we're starting right here. And we need to go to how many moles? Oh, how nice, because we're going from moles of this to moles of Fe2O3. So it's just a one-step conversion. That's going to be really a short one. So we only have to put our given. In fact, this one's so small, I'm just going to, there's the given right there. 2.4 moles of O2. I'll put that like that. And so now we need to do the mole-to-mole ratio. And if you forget that the mole-to-mole ratio involves looking, that we have to put the moles of what you're trying to find over what you started with, take a look here. We've got to cancel off this. So I'm just going to put moles of O2. And in this balanced equation, we have 3 moles of O2. And we're looking for Fe2O3 in this problem. And in the balanced equation, we have 2 moles of Fe2O3. And you can double check to make sure you set this up right. Moles of O2 cancels with moles of O2. So you're going to be taking 2.4 moles in your 2.4 in your calculator times 2 divided by 3. And that's going to, and let me make sure that I did answer the right question. How many moles are produced? Yeah, really short problem there. So good. With this one over here, the one next to it, well, it's going to be very similar. In fact, that's so quick, I'll just go ahead and do it. And you got this here, and we're looking for how many moles of Fe2O3. Well, in the balanced equation, we have 4 moles of Fe. So 4 moles of Fe, that's iron, metal. And since we're looking for Fe2O3, we still have 2 moles of Fe2O3. Moles of Fe will cancel out, and it's going to be, okay, there you go. You can get it set up there and do your own calculation work. On this next one, A and B, we're looking for liters of something. So I'm going to do the A there on here. In fact, actually tell you what, in class I went over all the A's. I'm going to go over and do the B right here. So set up this one here. We're given 0.8 liters of this. So what I'm going to do is on my little triangle up at the top, I'm going to just erase this stuff on the side. And let's see, we're given liters of C2H6. So I'm just going to call this C2H6. And we're started with liters. And we want to know how many liters of CO2 are produced. So now over here, we're going to call this side CO2. And that's what we want to find right there. And we're given liters there. So we're going to put our given here, 0.8 liters of C2H6. And I'm going to put that over 1. So we've got to do, now when we're starting right here at liters, we're going to have to divide by 22.4 liters to convert that to moles. Then we're going to have to do a mole to mole ratio. Then we're going to have to multiply by 22.4 to get this back over to liters of CO2. So I'm going to say there are 22.4 liters of C2H6 in 1 mole of C2H6. Okay, now, right now, cancel those off. Good, because we've set it up right if we can cancel those off. Now we need to do the mole to mole ratio. Excuse me, I just bumped the camera. The mole to mole ratio part here. So, let me put this over here. Now we've got 1 mole of C2H6 over here, and we want to cancel moles of C2H6, so we know C2H6 has to go down here. And in the balanced equation, we have 2 moles of C2H6. And we want to convert that into CO2 for this problem. And we look in the balanced equation, we have 4 moles of CO2. Now let's see if we set this up right. We should be able to cancel that with that, and yes we did. So now what we've done is we've jumped over, we now have moles of CO2 over here, and now we're going to convert those moles into liters is what we're trying to find. And let's see, we're going to say, well, we want to cancel this off, so we need to say 1 mole of CO2 is going to be 22.4 liters of CO2. That lets us cancel this. So now, there you go. Oh, okay, wait a minute. Now the 22.4 and the 22.4, we can cancel those. So that can cancel out there, just making those 1 over 1. So now we've got 0.8 times 4 divided by 2. And that'll be our answer in liters of CO2. Now when I cancel this off, I got to be careful. I did not cancel liters of CO2, so the answers will be in liters of CO2. Got to be careful when I cross that off. So let's go to the next problem now. And in this one, I'm going to do part B right here. So we're given grams of N2. Well, I'm going to go back to my little MVP triangle out here, road map that I made. So I'm going to put this off, just kind of cleaning it up. If you do this on your test, have one set up. So let's see. We are given N2. So I'm just going to label this N2, and I might as well draw that out. Write that out, 2.8 G of N2 gas. So there's our given. We've already got the first step done. Now what we want to do, let's see, we're looking for how many grams of Ti3N4. So I'm going to label this Ti titanium, trititanium, and this is N4, so that'd be tetranitride. So we are starting here at grams, okay, and we want to find how many grams of this one. So we're going to start here, going to convert it to moles. We're going to do our mole to mole ratio, and then we need to go back over here to grams because that's what we're looking for. The mass is measured in grams. So we're going to have a 3-step conversion. And so when we start right over here, when we can change the grams to mole, we need to divide by the molar mass of N2. And if you're not sure what to set up, well, every nitrogen on the periodic table has a, let's see here, nitrogen has a mass of 14, and we've got 2 of those. So we're going to say 28 grams of nitrogen, N2, is 1 mole. That's what we mean by dividing by the molar mass, because we're dividing by the number there. Now if we set this up right, those 2 cancel out, and they do. Okay, and so now let's trying to zoom in as much as I can, but I don't want to lose my MVP triangle up there. So now we need to do the mole to mole ratio. We're at that point. And if you're still not sure, we've got moles of N2 up here. So we need moles of N2 down here, but from the balanced equation. And in the balanced equation over here, we have 2 moles of N2. So we'll say 2 moles of N2. Okay, so that's because that was the compound we were given. And then we want to change it into Ti3N4, and we have 1 mole because there's no coefficient written there. So 1 mole of Ti3N4. Okay, now if we set this up right, moles of N2 cancel moles of N2. Cross these off as we go. Fill in your units. So now we have just finished our mole to mole transition, and we need to the question wants us to convert it into grams. And so let's see here. So now we want to say 1 mole of Ti3N4, N4, is going to be, well, we got to figure out how much that, what that mass is. And let's see here. When you look on the periodic table, let's see, titanium, I think we said earlier, titanium's mass was 48, and there's 3 of those, so 48 times 3 is going to give us 144. Okay, so now we got to add that to nitrogen's mass is 14, and there's 4 of those. And when we multiply that together, I think that comes to 56. So when we add those two together, it's going to equal 200, which is 200 grams of Ti3N4. Now, if we've set this up right, I can cancel this with that, which I can. There we go. So now this problem becomes 2.8. On your calculator, you do 2.8, divide 28, divide 2, times 200. And you can get that figured out. Or in your calculator, you can do 2.8 times 200, then divide 28, then divide 2 on there. Oh yeah, and I know what you're thinking. You're saying, hey, you could even cancel some of these out. Yeah, you can, but I'm not going to do that here. So that's how you get that one set up. Let's see now, coming over here to number 14. Well, for these last two, I'm going to go ahead and redraw the mole MVP. Look, there's no excuse for you all not to draw these, because look how quick it is to do this. It gives you a roadmap of where you're going, as long as you remember that this is mass in grams, volume in liters, and particles, either atoms or molecules. This is the given side, and this is what we're trying to find, going from left to right. So let's see. So in class, a couple of classes, I think I did 14A. I'm going to just work on this one. So in this particular, we're looking for how many molecules of NH3 are produced. That's what we're trying to find, NH3 in this problem. And we're given molecules of N2 since we're doing part B, so I'm going to call this side the N2 side. So we start with what's given, 1.5 times 10 to the 23 molecules of N2 over 1. Make sure we know that's a decimal point there. So when we're taking a look, we're starting here at molecules, right here at this part. We're going to have to convert that to moles. We're going to have to convert that into moles of NH3 by doing the mole-mole ratio. And then we're looking for molecules of NH3. We're going to come right back, right back over here to molecules. So we're going to divide by Avogadro's number, multiply by the ratio, the mole ratio, and then we have to multiply by Avogadro's number again. So let's say here, Avogadro's number, we're dividing by Avogadro's number to convert this to moles, times 10 to the 23 molecules of N2 is 1 mole of N2. Now molecules of N2 can cancel molecules of N2. Good so far. Now we need to do the mole to mole ratio. Now I have moles of N2 on the top up here, so I need to look to the balanced equation, and we have 1 mole of N2, so we'll say there's 1 mole of N2 in the balanced equation, and we want to find NH3. So we look to the balanced equation, there's 2 moles of NH3, because when we do the mole-mole ratio, we're based it on the balanced equation. If I've set this one up right, the moles of N2 here should cancel with those. Things are looking good. So now we've just converted it into moles of NH3. Now we're going to multiply by Avogadro's number to get this into number of molecules of NH3. And so let's see, we want to get rid of the moles here. And yeah, it makes sense. We got to multiply by Avogadro's number. So we're going to say 1 mole of NH3, which is ammonia, is going to be 6.02 times 10 to the 23 molecules. That's of NH3 and H3. And let's see if I've set this up right. I can cancel mole NH3 with moles of NH3. Now a nice thing here is that we can also, before we start multiplying, we've got Avogadro's number in the numerator, which we could cancel with Avogadro's number there, making those just 1 and 1. And so now it's a pretty easy problem. It's going to be this number times 2. Well, we could do that in our head. 1.5 times 2 is 3. It looks like the answer to this one should be 3 times 10 to the 23 molecules of NH3. So the last problem on this page that we'll go through. And let's see, on this one, I'm going to go ahead and do, let's see. I've been doing B. Let me just stay consistent. So on this particular problem, I'm going to come back to my little MVP roadmap. I'm going to erase what I put in the previous one. So how many grams of C3H6 are needed given this? So we're trying to find C3H6. We are given, in this part B, CO2. So I'm going to write CO2 over here. And we're starting with molecules of CO2. So we're starting right here, molecules of CO2. And we want to find out how many grams of C3H6. So when we come over here, we want to end up here. So to do that, we're going to have our given. We're going to, since we're going to the middle of the MVP triangle, we're going to divide by Avogadro's number. Then we need to jump across here by multiplying by the mole ratio from the balanced equation. Once we do that, we're going to have moles of this, of C3H6, and then we need to multiply that by its molar mass. So let's get that done. I'm going to put the given over here. We got 3.6 times 10 to the 24 molex, as I abbreviate it, of CO2. That's our given. I'll put it over 1. The next step, we need to divide, because we're going towards the middle of the triangle, by Avogadro's number. So we say 6.02 times 10 to the 23 molecules, molex, of CO2 is 1 mole of CO2. That's our conversion factor. Molecules of CO2 will cancel molecules of CO2. So let's see, we've come to here. Now we need to do our mole to mole ratio. So when we set this one up, I want to have moles of CO2 from the balanced equation down here. And we look at our balanced equation, we have 6 moles of CO2 for every, and we're trying to find C3H6. There are 2 moles of C3H6, 2 moles. C3H6. And if we did this right, moles of CO2 will cancel moles of CO2. That's a great way to check yourself. So now we've got moles of what we're trying to find, and the question wanted us to find grams of this. So now we need to multiply by the molar mass. And let's see, the molar mass of C3H12, well, let's see, 12 times 3, I can almost do that in my head. I think that's 36. Okay, yeah, that makes sense. See, 12 and 12 is 24. Yep, 36. Plus, and then we have every hydrogen is 6. So it's 36 plus 6. And, oh, I hope I don't get this. Should be, is that 42? 36, 37, 38, 39, 40, 40. Yep, 42 is the grams per mole is the molar mass here. So we're going to say, because I have moles of C3H6, 1 mole of C3H6 is going to be 42 grams of C3H6. Moles of that should cancel with moles of there. And let me see. All right, so in your calculators, let me scoot this over a little bit for you. So we've able to successfully cancel everything. 3.6 times 10 to the 24 divided by Avogadro's number. Okay, so divided by 6.02 times 10 to the 23. We're going to, now if you wanted to, you could, just to save you some time, you could say, okay, 2 goes in there once, 2 goes in there 3. Maybe that saves you putting in a bigger number. Okay, so anyway, and you probably cancel that one out, but there you go, there's that. So now we're going to get to the back page, the last part. And this was just a whole bunch of practice of making sure that you could successfully do the mole to mole ratio part, because a lot of people over vacation were having trouble with that. So we're converting this into that. So these are going to be what we're trying to find, okay? This is what we're trying to find, and this is what we're given. This is now, when we say given, this is the given side, okay? So what we're going to do is you're always going to put the CO2, moles of CO2, over the given, moles of C2H6. Now you got to look to the balanced equation. So our balanced equation is over here. And you know what? I'm going to rewrite the balanced equation right in the middle of our page. C2, C2H6 plus 7 O2s change into 4 CO2s plus 6 H2O, because that's just so high up out of the way. Oh, there we go. So here, I've just rewritten the balanced equation here, just so I can keep it on here. So let's see, CO2, 4 moles of CO2, and we had 2 moles of C2H6. Okay, we're trying to convert this into that, so we're trying to we want H2O on the top, moles of H2O. In the balanced equation, we have 6 moles of H2O, and we were starting with 2 moles. Okay, we'll say so the 2 moles of C2H6, and there's going to be our ratio for that one. So over here in this next one, okay, we're looking for, in our balance equation, we need to have moles of CO2, 4 moles CO2, and we're converting from oxygen, and in the balanced equation we have 7 moles of O2. So these would be here what you would do if you need to do a mole-mole ratio for this. Now, if you're getting to the point going, oh my gosh, this is getting boring, okay, cool, then hopefully you're getting it. We're trying to find water in this problem. The balanced equation has 6 moles of water, and there was 7 moles of O2. Okay, I'm going to start going a little faster here now. So we've got 2 moles of C2H6 are given. We had 7 moles of O2. Over here, 7 moles of O2, and then we had 4 moles of CO2. We're almost done here, everybody. And over here, let's see, we had 7 moles of O2 because we were trying to find O2, and we started with 6 moles of H2O. And let's see, 7 moles of O2, because that's what we're trying to find in this problem, and the given would have been 2 moles. Now when I say the given is 2 moles, I mean the given chemical was C2H6, so we're looking to the balanced equation. Oh, where's our balanced equation? I guess I better zoom out a little bit. So we need to look up there, and so 7 moles of oxygen, and we had 2 moles of C2H6. And lastly, then we're done with this review. Moles of H2O on the top, moles of CO2 on the bottom. You look to the balanced equation, 4 moles of CO2, 6 like that, and there you go. That's how you would set those up. So, please, 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 draw yourself, when you're starting these problems, make yourself a simple MVP triangle just so you know what you got to multiply. And then when you do that, when you're putting in, oh, so I lost my paper. Here we go. When you're filling these in, don't be lazy. Let me zoom in on one of these. Please put that it's grams of N2, and then when you do the next problem, you can see that can cancel. And then this, the moles of N2, because that's a double check for you that you're doing it right. If you don't put these in, you're probably going to get it wrong because you may real easily switch one of these, and this is your check to make sure you don't flip them. All right, everybody, goodbye.